Hi guys, welcome back. Hope you had a great weekend. We're on lesson 1-7, finding perimeter, circumference, and area. Most of this should be review for you, but geometry is a concept that we often shortchange in pre-algebra and algebra. So I'd like you to take a minute in your vocab sheets to get the definitions of perimeter and area for squares, triangles, rectangles, and circles. Should be very straightforward. So take a minute to do that. Pause the video when you are to finish that up. Okay, once you're done defining those things, I would like you to turn to page 50, and I'd like you to do the guided practice problems 1, 2, and 3. And that's doing area and perimeter problems. So I'd like you to do those 3. And as you start flipping that, I just want you to listen and make sure that you recall that our units for perimeter is a linear length. That means it's to the first degree. It's a distance. So for perimeter, we use things like feet, inches, yards, miles. We're talking about distance around something. Circumference is the same thing. Circumference is a linear distance, a first degree distance around the circle. So perimeter and circumference, we're going to always have first degree units. And we don't put it to the first power, but there's no exponents. Area, on the other hand, is a second degree unit because we're talking about in 2-dimension, not just a length. We're talking about a length and a width combined to get a square area. So I just want you to remember that we need miles squared, feet squared, yards squared. So make sure you've got your units correct for those guided practice. Okay, the next thing I'd like you to look at is a problem that looks like this. And it's a very typical problem that you might see on ACT, MEP, MME. Triangle QRS has vertices given. What is the proximate perimeter of the triangle? Well, if you don't have graph paper, you need to have enough awareness of what that means, QRS, that to find the perimeter, we need to find 3 different distances. And from our last unit, we learned how to use the distance formula to find that. So essentially, you're going to need to use the distance formula between these 2 points to find that distance, the distance formula between these 2 points to find that distance, and then the distance formula between these 2 points. Now, if you're perceptive, you'll see that Q and S both have the same y coordinate. So if you think about that, down here, Q and S having the same y coordinate means that that makes them a horizontal line. So for there, you can just use the one portion of the distance formula. The distance between 1 and 5 is just going to be 4 units. So you don't have to do quite as much work for the distance formula, but you go through the work on that. So I'd like you right now to please pause the video and find these 2 distances by using the distance formula. Add them all up and write down on your paper, for example 3, standardized test practice, which answer is correct. Okay, now we're going to go on to a trickier problem that involves a conversion. So I'd like you to look at this problem. An ice resurfacing machine is used to smooth the surface of the ice at a skating rink. This is called the Zamboni. The machine can resurface about 270 square yards of ice in a minute. So that's our rate. Just to review, square yards per minute, that's a rate because the numerator and the denominator both stand for different units. One's a length, one's a time. About how many minutes does it take the machine to resurface a rectangular skating rink that is 200 feet long by 90 feet wide? The first thing that should jump out to you is that our dimensions of the rink are in feet and our rate was given in square yards. So you should be thinking already that we're going to have to do some sort of conversion. So the first step you need to do is to figure out the area. And the area is, it's a square rink, so length times width, you get 18,000 square feet. But now we need to convert that. So since it's in square yards, we need to convert or figure out how many square feet are in a square yard. Okay, so if you think about this, the resurfacing rate is in square yards per minute. Rewrite the area of the rink in square yards. So this is what they do. 18,000 square feet, we want to convert square feet to square yards. So remember, in our conversion ratio, if we want the square feet to cancel, if this is in the numerator, we need to put square feet in the denominator so that they'll cancel. We put the unit that we want it to change into on top. Then as a review, how do we decide to put the 1 here? We always put the 1 with whichever unit of measure is larger. A square yard is larger than a square foot, so we make that 1. And then we use some reasoning. How many square feet are in a square yard? Well, there's 9. And as an example of that, if this is a square yard, it's 1 yard by 1 yard. Remember that a yard is 3 feet, so 3 feet by 3 feet. You can get the picture here that 1 square yard is equal to 9 square feet. Okay, so following this conversion, notice that square feet cross reduce, and then you multiply across to do 2,000 square yards. Okay, that's called unit analysis. You will use this a ton in chemistry, in biology, high school science. So then to finish that problem up, if our rink is now 2,000 square yards and we can cover, or it goes at a rate of 270 square yards per minute, we're just going to divide that, and it comes out to be about 7.4 minutes it's going to take us to cover that. Okay, the next question I want you to consider is something that looks like this. Describe how to find the height from F to EG in the triangle. Okay. Remember that the area formula for a triangle is 1/2 base times height. And the biggest thing I want you to remember is you have flexibility with a triangle to consider any of these sides of the base, as long as you can find a height that goes from a vertice perpendicular to an opposite side. So if we look at this triangle like this, notice that from point F, a perpendicular segment coming down and hitting EG is going to be considered our height. Why is that super easy to do? Because this is a horizontal line, so we can easily count that when it was here as horizontal. It's a line that we can easily count that the height is 1, 2, 3, 4, 5, 6. The height is 6. And our base is very easy to count because we don't have to use distance formula, things like that. It's a vertical line there. Okay, so what I'd like you to do is on page 51, please do the guided practice problems 4 and 5 only. All right, and then we'll finish up with one last question. And it looks like this. What do you do if you're given the base of a triangle? You don't know the height, but you're given the total area is 308 square meters. Okay. Well, please work through this example with me. The way I always do it is you start out with the formula written, 1/2 base times height equals area. Then you start making substitutions. You know area is 308, so you substitute that. You know the base is 28, so you substitute that. And then you just have to do a little bit of algebra to solve for h. You're going to cut 28 in half first, which is 14, and then divide both sides by 14, and you'll get your base. Okay, so tomorrow when you come into class, I'm going to be looking for clear vocab written for area, perimeter, circumference of all those shapes. And then I'll be looking for guided practice problems 1 through 3 and guided practice problems 4 and 5. So make sure you get that done and have a great day. We will see you tomorrow.